Welcome. This is another video. So in this video, the questions actually says use superposition theorem to find VO. So when the VO, they're using superposition theorem. So I'll do this example using superposition theorem. I'll also do it using mesh and the nodal analysis to confirm the answer. So what I'm gonna do, I'm gonna add a new slide, and then now superposition theorem. What I'm gonna do now, we said that the current source, we're gonna open circuit it, and then when we're using the voltage source, we're actually going to what? To close circuit it. So what's gonna happen now, I'm gonna start by closing the voltage source and using the current source first. So what's gonna happen now, I'm gonna be left with something like this, and then I'm gonna have here another resistor, and then I'm gonna have here I'm gonna have the current source here, and then that side I'm gonna have the voltage source. So I think this is what is it gonna look like, but we remember that I'm gonna replace this voltage source by a closed circuit. So what's gonna happen now, I have VO there, VO here, VO. Do I know the resistor? I know the resistor, that is 2 ohms. Let's see, and then I have the 3 ohms here, I have the 3 ohms here, and then I have what? I have the 5 ohms above here, I have 5 ohms. So that's it. We have 2, we have 3, 5, 2, 3, 5, and then we're gonna have the 5 amps here, 5 amps, and then we're given the direction with the arrow here inside the source that is going upwards. So that is what we are given. So what can we do with this one now? We want that voltage VO there, so using the superposition theorem. So the first thing that we can check is that actually there can be very many ways of doing this. There can be very many ways, but then we'll just see which one to use. So we have the current here traveling upwards, and then we have a resistor here. If you check this resistor, which is 5 ohms, that one the current will come upwards and then go to 5 ohms, also go to 3 ohms, and go to 2 ohms. So I'm checking the easiest way we can do this, but we can actually also apply on this thing, we can apply either the nodal analysis to find that voltage there, or else what we can do is that we can actually find the total current, and then after to find the voltage that is at the node. They're using node analysis. There can be many ways that we can do. Okay, but let's try to tackle the question. So now I can assume this V is V here, and then I'm assuming that this is a ground. So using nodal analysis, what I'm gonna say is that I'm gonna say V there minus what? Minus, remember the voltage at the ground is 0. I'm gonna say V minus 0, which is V here minus from here at the ground, that's minus 0, and then divide by 3 plus 2, and then that's gonna be which is this resistor and this resistor, since they are actually connected in series, and then that's gonna be 5. And then after that, that's the first current, or I can say actually this is current I1, and then that side the current is gonna go this side, which is I2. So we actually know that this 5 amps goes straight to my node there, which is node V. So my current goes straight to that node here, and then I'm just gonna have the I, let's say this one it's I3, and then I3 is equal to what? Is equal to 5 amps. That means now I have I3 which is entering to the nodes, which is gonna be equal to, remember according to the nodal analysis, that the sum of currents entering the nodes are equal to the sum of currents leaving the node. That means now the I3 is the only one that's entering, is gonna equal to be what? I1 plus I2. And then if you see here, I3 is actually gonna be what? Is going to be 5, and 5 amps is entering into that node. And then after that 5, I'm having 2 here, or let me write here. I'm having 5 is equal to, I'm having I1, which is leaving the load, which is gonna be V minus the voltage in the ground, and then divide by 5, and then plus for I2 I'm going to have V minus, again coming to this side, we encounter the 0 voltage, which is the one in the node, and then that's gonna be divide by 5, which is this one. Remember, this 5 was for the sum of 3 and 2, and then now we can actually cross multiply, and then if we multiply here by 5 both sides of the equation, I'm gonna get 25. 5 times 5 is 25. That's gonna be equal to V plus the 5 cancels 5V, and then 25 is actually 2V, and then V should be equal to 12.5 volts. So that's how I can find that voltage there. And then what I can do is that I can use the I can go back now. Since I said I1, if you check I1, I said is equal to what from here? Is equal to V minus 0 over 5. That means now I1 is actually equal to, and in place of V we put 12.5 minus 0 divided by 5, and then I try to write that better, divide by 5, and then that's gonna be 12.5 minus 0 divided by 5. I get 2.5 amps. So after getting that current I1, which is 2.5 amps, I know that 3 ohms and the 2 ohms, they are actually in series. That means they will have the same current, which is 2.5. That means I can calculate VO prime, and then that VO prime, or else I can leave it as a current like that, and then I'm gonna say this is I prime, and then if we check, the direction is going downwards. And then I'm gonna add a new slide here now, and then I'm gonna calculate due to what now? Due to the voltage source. And then when we calculate due to the voltage source, that means we're gonna open circuit the current source. So now let's see what's gonna happen. That means we're gonna have this resistor here, and then let me see, I'm having the other resistor, and then I'm having this, and then I'm having the other resistor, I'm having this, and then this is what our circuit is gonna look like. And then try to draw that better. This is the circuit that we have, and then I can see that here we have 2 ohms. I'm gonna say 2 ohms here, and then I can see that there above we have 3 ohms, then this is 3 ohms, and then I can see that we have 5 ohms again here, 5 ohms, and then I have 12 volts, and then with the signs plus or minus, or the polarity. And then now you can see that we have 2, 3, 5 and 12, which is here 2, 3, 5 and 12. We removed the current source and we replaced it by what? By the open circuit. So what's gonna happen now, we can see that all our resistors are in series. That means I can find the equivalent resistance, which is gonna be R equivalent, which is gonna be 2 plus 3 plus 5, and this is gonna be 5 plus 3 is 8, and then this is gonna give me a 10, and then this is 10 ohms. And then I can find the total current now, which is gonna be what? Voltage divided by resistance, and then I have 12 volts divided by the resistance, which is 10 ohms. And then if I go on and say now at 12 divided by 10, I'm gonna get a 1.2 amps. So now what's gonna happen is that now this is the total current that is emitted by the 12 volt source, and then this current I total is equal to what? 0.2 amps. And then this current, I know that since all these things are in series or resistors, that means at 5 ohms our current is 1.2, at 3 ohms our current is 1.2, at 2 ohms our current is 1.2. That means now these are also, because remember what the voltage we wanted is the one that is where, that is at 2 ohms. So the current that it was traveling 2 ohms, we find firstly with the current source, and then we found 2.5 amps. We found secondly with the voltage source, we found 1.2 amps. Now let's check the direction. So first example, the current was traveling downwards because you can see the direction of the current there. And then the second example, the current was also traveling downwards, because remember now that the current will be traveling that way, that way, that way, so it's still downwards there. So what's gonna happen now is that now we can call this I prime prime. So now I'm gonna say I, the actual I that is at 2 ohms now, is gonna be I prime plus I prime prime, and they are both positive because the direction is the same. And then I prime, I got here 2.5 plus I prime prime, which is 1.2, and that should be 3.7 if I'm not mistaken, and this should be 3.7 amps. 2.5 plus 1.2, and then that's 3.7 amps. Remember, we wanted the voltage, that means now VO will actually be equal to I multiplied by R according to Ohm's law. That's 3.7 multiplied by 2, and then if I'm saying 3.7 multiplied by 2, I'm gonna get 7.4 volts. So that's it. That's the answer for that question now.